Assalamualaikum warahmatullahi wabarakatuh, and a very good day. So today me and my friend going to go through data structure and algorithm on sorting. So basically sorting is a list of algorithms, different algorithms which can be used to sort any list of array that we want to sort, whether in ascending order or descending order. So from the slides we have multiple kinds of algorithm. For example, here we have bubble sort, selection, insertion, until heap sort. So in this video, me and my friend going to explain about 4 different kinds of sorting algorithm, and let's go through one by one. Alright, so the first one, based on this final year paper, we have a list of elements which is in unsorted format. We have 16, 30, 24 until 50, and in this question, the first question wants us to sort this element, this list, by using selection sort algorithm, and the second question wants us to sort this list by using merge sort algorithm. So without further ado, let's go to question number 1. Show the steps to sort this array in ascending order using selection sort algorithm. So what we're going to do is we're going to sort this list by putting the smallest element on the left side and the biggest element on the right side. So here I already extracted the list, and you can see the list inside the screen. So now how selection algorithm works is selection algorithm will be comparing index by index. So for example, the first step in this case is index 0, which resided by element 16. So what we're going to do is we're going to compare 16 with the other elements, and we need to find whether there is any element which is smaller than 16, or any element which is the smallest inside the list. And we have 30, 24, 7, 25, 62, 45, 5, 65 and 50. And here we can see that element 5 is the smallest element and is much smaller than 16. So what the algorithm will do is it will replace 5 with 16. So 5 will be residing in index 0 and 16 will be residing in the previous index of element 5. And basically that's how selection algorithm works. And we're going to continue with the next index. Compare it starting with 24 until 50. We can see that 7 is the smallest element within the list. So 7 will be replacing 30 in the list. So here we can see that 5 and 7 is considered as the sorted list, while 24 until 50 can be considered as unsorted list. So now we're going to continue with the next index, 24. We can see that 16 is much smaller than 24, so 16 will be replacing 24 and 24 will be replacing 16. And then we continue with the next index, 30. the smallest element within the list is 25, so 25 will be replaced, the smallest element is 24, so 24 will be replacing 30. And then we continue with the next index, 25. There is no element which much smaller than 25, so 25 will be staying in its own index without replacing 25 with any other elements. And then the next index is 60, so we have 30 as the smallest element, so 30 will be replacing 62. And then continue with 45. There are no any elements which is smaller than 45, so 45 will be staying in its own index. And then we have 62, and here we can see 50 is much smaller than 62, so we will be replacing 62. And then 65 and 62. 62 is much smaller than 65, we will be replacing 65. Now we have only one element left, which is 65. 65, we don't have any other elements which we can compare it with, so we're going to put it right here. Right, so now as you can see what we have a new list which has been sorted by using selection algorithm. And as you can see, on our left side we started with the smallest element, and on our right side we have the biggest element, 65, and all the elements are positioned in ascending manner from the smallest to the biggest element. So basically that's what selection algorithm is. And here I'm going to show you an example, a visual example. So here we have a list of elements, unsorted elements. We have 22, 21, 24 until 23. So what we're going to do is we're going to run selection sort, and here in the screen you could see how the algorithm works. So I'm going to press go. So now it will check every element, it will find the smallest element in the list, and then it will replace the smallest elements with the first index, and then continue with the next one. 10 is the smallest element, it will replace it with the second index. So we can do it a little bit faster. You can see that the elements are replacing each other by comparing their element size from smallest to the biggest elements. So now the output will be element 3 until element 24. It is sorted by using selection sort. So that's it for selection sort. Okay, now we already completed question number 1 for selection. We're going to explore the next chosen algorithm based on the question, and that is merge sort. So what is merge sort? So a merge sort algorithm, we have 3 steps that the algorithm will be doing. So the algorithm will divide the list into parts, and then it will sort each parts or group, and then it will merge all group together, creating one single list which will be in a sorted manner in terms of ascending order, meaning from the smallest elements to the biggest elements. So for divide, we have multiple ways that we can do, but for this step, for this question, we're going to divide the list into 2 groups. So we have how many elements? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. So we have 10 elements, and we're going to divide these elements into two groups. So what we can do is we can take the first 5 elements here. This is the first group, and then we're going to take the second the second group of elements, and we put it here. And you can see here we have two groups that we already divided. So what now? We're going to continue with the next step, sorting. So remember the selection algorithm that we used. So we're going to use selection in order to sort the list of elements from smallest to the biggest. So let's start with the first group. So for the first group started with element 16 until 25. So the first index will be compared with other elements. We need to find a smaller elements, and in this case we have 16, and we need to find any elements which is smaller than 16. So we have 30, 24, 7 and 25. The smallest element that can be compared with 16 is 7. So 7 will be replacing 16. So 7 will be sitting in index 0. And then we continue with the next index. We have 30. We compare it with 24, 16 and 25. The smallest elements that we can find is 16. So 16 will be replacing 30. And basically that's how it works. So we continue with the next index, 24, and then we have 30 and 25, which means 24 is the smallest, so it will stay in its own index. Then we continue with index 30, index 0, 1, 2, 3, index 3, and the element is 30. So we're going to find if there is any element smaller than 30. We have 25, so 25 will be replacing 30. And 30 is the last element, therefore we just let it stay in its own index. And here what you can see is we already sorted this element into ascending order format, which you can see here it started from element 7 until element 30. So we can consider this group as sorted. And now we need to continue with the next group here. So we started with element 62. So we have 5 as the smallest. We're going to place, and then 45. 45 is the smallest, and then we have 62. We compare with 65 and 50. We have 50 as the smallest elements than 62, and then we have 65, which are bigger than 62, so we're going to replace it here. And the last element will be 65. There is no any other elements that we can compare with. So we have completed group 2, and we already sorted the elements from 5 until 65. So now we already completed the second step, sorting for both groups, meaning that both groups are already sorted accordingly. So what we need to do now, we need to compile both groups into a single list. And here what we need to do is we need to compare every index based on group. And what I mean by comparing index based on group is 7 and 5 is the index 0 for each groups, right? So we're going to compare 7 and 5. Which one is the smallest? So 5 is smaller than 7, so 5 will be sitting in the first index. And then 7 and 45. So 7 is much smaller. 16 and 45. 16 is much smaller. 24 and 45. 24, 25 and 45. 25 is much smaller. 30 and 45, we have 30. And then we already used all elements for the first group, meaning the rest of the elements will be on the second group, as you see in the screen. So what we can do is, since these elements are already sorted, we can just merge it without comparing the two groups like we previously did. So now we have a sorted element that we sorted by using merge sort algorithm. And here you can see our smallest element 5 is on the left side of the list, and our biggest element is on the right side of the list. So basically that's how merge sort algorithm works. And here we can visual merge sort. We will use this list which not sorted at first, as you can see in the screen. So when we press sort, it will compare. First it will divide the elements into group. See, it will divide the elements into group, the second group, and then here another group, and we will compare it. Alright, as you can see here, we have 11 until 24, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 elements, and the first group here already sorted, so the system will continue with the second group. And I'm going to make it a little bit faster. So it will sort the second group, and now we are going to have two groups. See, the first group and the second group. Both groups are already sorted in ascending order, and what the system will do now is it will compare the index for both groups, just like what we did just now. So I'm going to make it a little bit faster. See, the list is already sorted by using merge sort, as you can see in the screen. So that's it for merge sort algorithm.
Okay, this is sort example of array, okay, a set number of array, and we're gonna use the bubble sort. Okay, what is this bubble sort? Bubble sort is basically a comparing two value, and then the highest number will be moved to the right. Okay, for example, let's say we're gonna take number 16 and 30. Okay, since 30 is higher than 16, so 30 gonna stay right on the right side. Okay, after that, okay, 30 will compare with 24, right? It seems that 30 is higher than 24. So what we do is going to swap. It's gonna swap the position. 24 is gonna move to the left, and 30 gonna move to the right. All right. And now we're gonna compare again. 30 with 7. Okay, 30 with 7. Since 30 is higher than 7, so what happened is 30 is gonna repeat. Move to the right. Okay. Okay, after it's complete, and then it's gonna repeat again, compare with 25, since 30 is higher than 25. So, oops, sorry. So 30 is gonna move right here. Okay, now 30 versus 62. It seems that 62 is higher than 30. So 62 gonna stay right here. Okay, gonna stay on the right, and then 62 gonna compare with 45. It seems that 62 is higher, so we're gonna swap. Okay. Gonna swap right here, and then it's gonna compare again with 5 since the 5 is higher. So we're gonna rotate here. It's to 65. 65 is higher. 65 compared with 50. 65 is higher, meaning 65 gonna stay right here. Okay. So first complete, and then we're gonna do it again. 64 compared with 24, right? So 24 stay. 7 we're gonna move right here. 24, 35, 25 to 30. 30 stay here. 30, 35, 45. 45 stay here, and then you're gonna move 45 to here. Okay, compare 62 stay right here, and then compare 50. Alright, so second is complete. And then we're gonna repeat again. Okay, 16 and 7. 7 gonna stay here, stay to the left. 16 go to the right. Again, 24, 24 stay versus 25. 25 stay. 25 is 30. 30 stay. 30 compare 5, move right here. Oops, move right here, and 30. And it's gonna repeat, it's going to be repeat. But at the end of the day, what will happen is going to be, this is will be the end of the result. I'm gonna like skip. I'm gonna Okay. So this is basically a bubble result. Basically, comparing two value. The higher value will be go to the right, and then it will compare to the next, which is right here. If it's the higher number again, go to the right. Smaller, go to the left. That is bubble sort. Okay. This is insertion sort. Insertion sort is basically we comparing one value. Okay, we compare one value toward to the left side. Okay, for starter, we're gonna take number 16. Since 16 is the zero, in zero position right here. So we're gonna compare to the left side of the value, which is no value on the left side. Therefore, the number 16 is gonna stay right here. And then we move up to the number 30. We compare to the left side, which is number 16. Since 30 is higher than the value of 16, therefore the number 30 is gonna stay. And then we move to number 34, compare to 30. Okay, we're gonna temporary put right here. Since 30 and 24, that 30 is higher than 24. So therefore 30 obviously is gonna stay on the right side. And then 24, and then we're gonna compare again, 16 and 24. Since 24 is higher than 16, therefore it's gonna stay right in between. Okay? Right, so it's complete, and then we're gonna take number 30. We're gonna compare to with number 7 compare with the left side, which is 30. Since 7 is lower than 30, so we're gonna put right here, and then 30 obviously gonna move to the right. And then we're gonna compare with 24. Since 7 and 24 is higher, so therefore 24 gonna stay on the right side. So we're gonna put temporary position right here. We're gonna compare again. 16 and 7, 16 is higher, then 16 is gonna stay here, and 7 go to the left side. Okay, and then we move to the 25. Compare again with the left side, which is 30. 30 could move to the right. Compare 24, 24 and 25. 25 is higher, therefore stay. Then 62. Compared to the left side, it's gonna stay. We're gonna take the 45. So 45 compared to 62, so move to the right. 45 compared with 30, it's higher, therefore gonna stay right here. Okay, same again. 5 compared to 62, again, gonna stay right here. 62 moves right. Okay, compare with 45, 45 stay. 30 stay to the right. 25, 30 stay right, stay right. 60 stay to the right. 7 move to the right, and 5 move to here, to the far left. Okay, again, 65 compared to 62. Okay, 62 move to the right. See if I stay here. Okay, 50, 62. Obviously, 62 gonna higher. Sorry, 62 is higher. 50 compared to 65. 65 move to the left, and then it's here. Last, 62 compared to 65. Move right here. Okay, so this is basically insertion sort.